Welcome to Informal Fallacies, the Part 3 lecture. This time we will be talking about hasty conclusions, small sampling errors, unrepresentative samples, questionable cause, questionable analogy, questionable statistics, and the questionable use of good statistics, including the special case of biased polling. Now, this is our last major section dedicated specifically to named lists of informal fallacies, but this doesn't mean that we have covered all the informal fallacies that are out there. There are many, many more. Remember that some of these categories are quite broad, and some of the named fallacies are subsets of other broader categories. Last time, for example, we saw that a non sequitur was a very broad category. This time, we will see that a hasty conclusion is a broad category as well. In our first look at informal fallacies, we examined several appeal fallacies, such as appeal to authority, appeal to ignorance, and so on. But there are dozens, if not hundreds, of possible fallacious appeals. One could appeal to force, might mate's right, or appeal to pity, or appeal to fear, many commercials do this, or appeal to anger, and so on. My point is simply that you shouldn't take the list we have discussed to be comprehensive. It is good to remember the most specific fallacy types, but it is also important to learn how to recognize bad reasoning and the very broad fallacy categories. At that point, one can then ask if there is already a more specific name for the flaw in reasoning being committed. With all that said, let's move on. I've mentioned this in previous PowerPoints on informal fallacies, but it is important enough to mention again. With the informal fallacies, there are often fallacious and non-fallacious versions. There are good uses of statistics and fallacious uses. There are sometimes legitimate reasons to draw conclusions fairly quickly without it being a hasty conclusion fallacy. Good analogical reasoning can be quite strong, and there are plenty of polls that are unbiased. One of the fallacy types not really discussed in this lecture, but mentioned in Cavender and Kahane's book, is the false charge of fallacy. One doesn't want to jump to the conclusion that a fallacy is committed because it might superficially look like one. Remember, for example, that in the last lecture there are perfectly legitimate slippery slope arguments, and there are slippery slope fallacies as well. With inductive logic, unlike with deductive logic, you cannot simply look at the form of an argument and tell if it is a fallacy. Content matters. So, while a deductive fallacy, like affirming the consequent, is always fallacious, even something like attacking person's character might be relevant and not an ad hominem fallacy if that person's character is actually what is at issue in the argument. Now, the hasty conclusion is a very broad fallacy type. One is guilty of this fallacy when one reaches a conclusion based on information that is relevant, so it isn't a non sequitur, but is nevertheless insufficient for reaching that conclusion. Here is an example. Suppose that you are missing your cell phone. You thought you had it in your pocket, but when you reach for it, it isn't there. Should you immediately jump to the conclusion that it is stolen? Probably not. It certainly might have been stolen. The fact that your phone isn't in your pocket is relevant to the possibility of it having been stolen. But if you are a normal person with a normal memory, you probably forget where you have placed your possessions more often than you have your possessions stolen. It would be more reasonable to look in several places for your cell phone before concluding that it had been stolen, unless you have some other good reason to think that it had been stolen. Again, notice the nature of informal fallacies and inductive reasoning here. If you are a person with a perfect memory, such that you were certain you put it in your pocket just a moment ago, and the only thing that had happened to you in the meantime was that somebody bumped into you on the side that you carry your cell phone on a crowded street, well then, concluding that your cell phone had been stolen might not be a hasty conclusion for you. It sounds instead like you have a good reason to think that your cell phone was pickpocketed. But under normal circumstances, you probably reached a hasty conclusion. One more very important thing to note. Just as with other fallacies we have been discussing, whether or not you were actually right. Here is a rather amusing example of a commercial about reaching hasty conclusions. Remember that in order to pause the PowerPoint, you can move your mouse cursor to the bottom of the screen. A menu should pop up. On one of those menu options, there should be a sub-option to pause the presentation. Once you do that, you can click on the image to start the video. The video should open up in a new browser window. Once you are finished viewing it, just click back into the PowerPoint and it should restart again. I'll count down from 5 to give you time to pause. 5, 4, 3, 2, and 1. Okay, the fallacy of using too small of a sample. One commits this fallacy when one makes an inference about a property or properties of a population through the examination of too small of a subset of that population. We have talked about sampling before, and in that example I believe we used a gumball machine as well. It works well as an analogy. See? Reasoning by analogy. We are using our concepts. Okay, imagine that you have a gumball machine, but that the glass of this gumball machine is opaque, so that you don't know what kind of gumballs it contains. Now imagine that you buy 2 gumballs, and that both are cherry, and so you reach the conclusion that all the gumballs must be cherry. What is the problem here? The problem is that the gumball machine likely contains hundreds of gumballs, and yet you only sampled 2 of them to reach your conclusion that they were all cherry. Suppose that the gumball machine contains equal portions of cherry and grape. If that were the case, then your odds of getting 2 of the same flavor. Okay, here is a very nice explanation of the problem with using small sample sizes. It is about 10 minutes long, but it's very good and it explains the issue well. Again, I'll count down from 5 so you can pause to play it. 5, 4, 3, 2, and 1. Here is another kind of sampling error, the unrepresentative sample. One commits this fallacy when one reaches a conclusion about the property or properties of a given population based on a sample of a subpopulation that doesn't reflect the relevant characteristic or characteristics of the population. We already went through an example with the gumballs that you have hopefully considered. If all the cherry gumballs are sitting at the bottom and all the grape ones are sitting at the top, then even if you take a large sample, you are still likely to get all cherries and will reach the faulty conclusion that the gumball machine contains only cherry gumballs. One way to fix this would be to mix up the gumballs in the machine, or to pick them out randomly instead of using the dispenser at the bottom. Here's another example for variation. Suppose that I am your manager and that I want to know how you spend your time at the office. To do this, I decide to sample what you do during the day. So, every workday that month I come in between 12 noon and 1 p.m. and I notice that you are never at your computer like you should be. Sometimes you are chatting with people, sometimes you are at the soda machine, sometimes you are not at the office at all. I reach the conclusion that you are a terrible employee and I start writing up your pink slip. How might my reasoning be flawed here? Any ideas? Well, one obvious problem is that I am always sampling how you spend your time between noon and 1 p.m. Many employees habitually take their lunch at the same time every day. If this was your normal time for a lunch break, it would not be unusual or derelict for you to be chatting with other employees or at the soda machine or out of the office entirely. All the other hours of the day you might be glued to your chair working feverishly. At lunch you might be taking your much needed and deserved break to keep your energy up. My poor reasoning could cost me my best employee and could get me sued in the bargain. Again, you should notice that a small sample is just a subset of the unrepresentative sample fallacy. Having too small of a sample is just one way to get samples that are actually unrepresentative. Questionable cause. This fallacy is committed when we conclude that something was the cause of something else without sufficient reason or warrant for reaching that conclusion. There are several ways that we might fail to have sufficient warrant. Here are just a few. The cause might be questionable because of any of the fallacies regarding causation we have already mentioned, such as the post hoc fallacy, before, therefore the cause of, or the fallacy of ignorance. Maybe the cause postulated contradicts a well-founded higher-level reason to reject that cause. Of course, higher-level reasons can themselves be rejected. But if we have a well-supported higher-level reason, then we have to have good evidence to overturn that claim. If I come home and find that my house is a mess, angry gremlins might be the cause of it. But given that I have a lot of higher-level reasons not to believe in critters such as gremlins, I could probably reject that as a cause unless I had a very good reason to reconsider it, such as maybe finding one of them caught in a mousetrap. Having too small of a sample or an unrepresentative sample can also lead to falling for the questionable cause fallacy. Suppose I have a population and find that 70% of the people who eat liver 3 times a week die on average 3 years earlier than non-liver eaters. This might seem significant, and perhaps it would be, but if my sample is not representative, suppose all the liver eaters I sampled were people who were also smokers, then my study likely isn't very good. Likewise, if I only sampled 2 liver eaters, pure chance could have thrown off my survey. Reasoning by analogy is incredibly useful. It can go wrong very fast, however, if one is comparing 2 or more things that seem similar in some respects, but are not similar in the relevant ways. There are lots of ways analogies can go wrong. Here are just a few. Too small of a sample size might result in one making a bad analogy. Again, one might use an analogy in spite of it contradicting a well-established higher-level theory. The items said to be alike might not be alike in the relevant respects, even though they are superficially alike. Here are a couple examples of weak analogies. As always, Futurama is a great source of humorous fallacy examples. The other is an amazingly bad analogy from a car commercial. I have no idea why you have to turn YouTube's safety mode off to view the car commercial. As far as I can tell, there's nothing offensive in it apart from its assault on reason. But my guess is that YouTube's auto-translate for closed captioning mistranslated something as sexual and then censored its own mistranslation, and that this is what's causing it, but that is only a guess. Anyway, here are 2 examples. Questionable statistics. One can fall for questionable statistics when one accepts as authoritative statistics that are unlikely to be accurate. These statistics might be flawed for numerous reasons, just some of which are as follows. Statistics might be impossible to know, or to know with the accuracy implied. Suppose, for example, that you were told that 1/3 of Americans are racist. How could this be known? Would 1/3 of Americans admit to being racist in a poll? Are they being judged as racist by some action they commit or position they hold? If so, then it would be more accurate to say that 1/3 of Americans commit some action or hold some position X, since it might be up for interpretation whether such an act or position is always racist. Another common problem is the margin of error of studies. The people conducting the studies often understand the margin of error, but the people using the studies and oftentimes when the studies are published in popular mediums, such as newspapers and in broadcast television, the margin of error is not given. Suppose I say that this year support for the death penalty is 49% and last year it was 52%, and that therefore support for the death penalty is dropping. Is this a good conclusion? Suppose that the margin of error for these studies is 6%. Well, then maybe this year it is really the case that 54% support it, and last year it was really the case that 51% of the people did. That is within the margin of error, but that means that it actually increased. Oftentimes, changes in statistics might be a result of how those statistics are calculated instead of any real-world changes. Suppose that the government wants to show a drop in unemployment. One way to do this would be if unemployment actually dropped. But another way would be to redefine what it is to be unemployed. If you count people with just a couple of hours of work a week as employed, when you didn't last year, unemployment appears to drop. Or if you don't count people who haven't applied for a job because they have given up as they've applied to all the jobs they're qualified for in their location, then it appears to go down. If the police want to make crime statistics look better, they might be able to say cases are closed even though those cases might not be solved, or redefine what it is to consider a violent crime, and so forth. Such statistical sleights of hand are often hard to spot. This is why it becomes helpful to learn which news sources or watchdog groups are more trustworthy and which manipulate the facts to their own ends. Of course, in order to do this, one needs to check up on these groups oneself occasionally to make sure that they are being honest. Even good statistics can be misused if one uses them to reach conclusions that are not warranted by those statistics. This can happen if one doesn't really know what those statistics actually implied. This is often the case with scientific information. Another major problem is the problem with causation that we have discussed, especially that of confusing correlation with causation. Two things might be correlated, but it might not be the case that one causes the other. Thus, a perfectly good study might show a correlation between two facts, A and B, and yet A doesn't cause B. Maybe B causes A, or maybe A and B are both caused by C, or maybe A being correlated with B is temporary coincidence. A correlation is a good reason to suspect causation, but it is not sufficient. Buying new cars, for example, might be correlated with a strong economy. But buying new cars doesn't cause the economy to be strong, though it likely helps car companies. It is far more likely that when people have more money, one of the things that they happen to do is buy new cars. People who play video games are less likely to have heart attacks than people who play bingo. But it is unlikely that video games help prevent heart attacks or that playing bingo helps cause them. It is far more likely that younger people who tend to play video games are less likely to have heart attacks than older people who tend to play bingo. One shouldn't think that these are the only ways that good statistics can be used wrongly either. There are too many ways to list. There's an old saying that there are lies, damn lies, and statistics. This is of course not true. Statistics are incredibly useful. Science wouldn't be able to progress very far or very fast without statistical analysis. Nevertheless, there is truth to the fact that statistics can be used to deceive, and further, that people can be deceived by them unintentionally. One form of a questionable use of good statistics is questionable polling. Polling might be questionable because of too small of a sample or an unrepresentative sample, but with polling, an especially worrisome issue is the question of wording. Both the way questions are worded and the questions that come before the particular question that the pollsters are interested in sharing can have a terrific influence on the outcome of polls. Even the places that some people are polled can have a dramatic effect on their responses. People answer survey questions differently if they have just left church, or if they have just had a drink, or if they are relaxing, or if they are hungry, and so forth. Indeed, psychological studies have shown the surprising results that people tend to answer questions more conservatively if they are within eyesight of a hand sanitizer machine, or if they have had just a couple of alcoholic beverages. Very subtle things can affect how we answer questions. This doesn't mean that polling or statistics in general can be ignored. They are very useful tools. But it means that one needs to make every effort to poll fairly. One needs to learn who tends to take reputable polls, and when possible, one needs to know the wording of all the questions asked. Once again, wording can be very important. Here is an example. Do you suppose that people would answer these two questions the same way? Do you support allowing doctors to assist those dying of a terminal illness to die painlessly if the patient pleads with them to do so? Versus this question. Do you support allowing doctors to murder the terminally ill before they die naturally? I think that chances are that many people, at least, would answer these two questions differently. Ideally, polls are used to find out what people actually believe. Here is an excellent example of how polls can be used to get a desired answer instead. This is from a series called Yes Minister and Yes Prime Minister. One is the sequel to the other, and I forget which one this is from. I think it is from Yes Prime Minister. This series contains many marvelous examples of fallacies and manipulation using language. Once again, I'll count down from 5 so that you can pause to play the clip. 5, 4, 3, 2, and 1. Okay, while we're on the subject of polling, it is worth mentioning the problem of push polling. Push polling is a tactic often used for political or social ends in which people with a particular ideology or goal ostensibly take a poll with the real aim of manipulating the beliefs of the people whose beliefs they are pretending to measure. For example, in the 2000 primary election, George Bush's people used the push poll to undermine Senator McCain's campaign by asking people in a poll if they would be more or less likely to vote for Senator McCain if they were to find out that he fathered an illegitimate black child. Of course, there was no reason at all to suspect Senator McCain had ever done such a thing, and Bush's people knew this. The point of the poll wasn't really to find out how people would feel about this possibility. It was to spread the rumor in a particularly targeted population that McCain had fathered an illegitimate black child. It was a type of whisper campaign against Senator McCain. And that is the end of the presentation for this module. I hope that you found it useful. The next module should be especially interesting as it will be discussing some of the psychological issues that can get in the way of good reasoning. Until next time.